There exists a place where sound does not travel, where air does not soften light, and where the horizon feels unnaturally close. This place is the Moon, Earth's only natural satellite, orbiting at an average distance of approximately 384,400 kilometers. For centuries, it remained an object of myth, poetry, and distant observation. Yet in the 20th century, through the combined efforts of scientists, engineers, and astronauts, humanity transformed the Moon from an unreachable symbol into a physical destination. On July 20, 1969, the lunar module Eagle descended toward the Sea of Tranquility. During the final moments of descent, its onboard guidance computer began issuing a series of alarms, most notably the 1202 and 1201 executive overflow warnings. These signals indicated that the computer was overloaded with tasks, raising immediate concern within mission control. Flight Director Gene Kranz would later recall that the decision to proceed with the landing depended on the rapid assessment of these alarms by computer engineer Steve Bales. The system, though strained, remained operational. As fuel reserves dropped to less than 30 seconds, Neil Armstrong assumed manual control of the spacecraft, steering it away from a hazardous field of boulders. Moments later, the transmission reached Earth. "Houston, Tranquility Base here. The Eagle has landed." With that statement, humanity had arrived on another world. Yet what awaited there was not merely a new landscape, but an entirely foreign environment, one that defied the fundamental conditions required for life. The surface of the Moon is covered by a layer known as regolith, a fine, powder-like material formed over billions of years by constant micrometeorite impacts. Its texture, as described by the astronauts, resembled soft dust, yet its particles were sharp and abrasive. Upon descending the ladder, Armstrong noted that the surface was fine and powdery, easily displaced by even the slightest movement. Gravity on the Moon is approximately 1/6 that of Earth, measuring about 1.62 meters per second squared. This reduced gravitational force profoundly alters human movement. Walking in a conventional sense becomes inefficient. Instead, astronauts adopt a loping or hopping motion. Despite the lower gravity, mass remains unchanged, and objects retain their inertia. Equipment still resists acceleration, requiring careful control with every movement. Buzz Aldrin described this unfamiliar sensation as surprisingly manageable, stating that movement felt almost like hopping. Yet beneath this apparent simplicity lay constant awareness. Every action required adjustment to a world governed by different physical rules. Perhaps the most striking feature of the lunar environment is the absence of atmosphere. Without air, sound cannot propagate. No wind moves across the surface. No rustling accompanies motion, and no external noise exists. Astronauts did not hear their own footsteps. Vibrations traveled only through their suits. The Moon is a realm of complete external silence. This silence is accompanied by an equally unfamiliar visual experience. Without atmospheric scattering, the sky remains black even under direct sunlight. Shadows are sharp and absolute, while illuminated surfaces are intensely bright. There are no gradual transitions between light and dark, only stark contrast. Temperatures on the Moon vary dramatically, ranging from approximately plus 120 degrees Celsius in sunlight to 170 degrees Celsius in shadow. Yet in the vacuum of space, heat transfer occurs primarily through radiation rather than convection. As a result, an astronaut can feel warmth under direct sunlight while standing mere centimeters from extreme cold. Advanced life support systems within the spacesuit regulate these conditions, maintaining a stable internal environment. Amid these physical extremes, one sight stands apart as profoundly transformative: the view of Earth. From the lunar surface, Earth appears not as an immense world, but as a small, luminous sphere suspended in the darkness of space. Its blue and white colors contrast sharply with the monochrome landscape of the Moon. This perspective was first captured in the iconic Earthrise photograph during the Apollo 8 mission. For many astronauts, this view produced a cognitive shift, later described as the overview effect. a heightened awareness of Earth's fragility and the interconnectedness of all life. Standing on the moon, one sees no borders, no nations, no divisions, only a single, delicate world. The lunar surface itself presented unexpected challenges. The fine regolith adhered to spacesuits due to electrostatic charging, clinging to fabric and equipment. Upon re-entering the lunar module, astronauts reported a distinct zapping, often compared to burnt gunpowder. This zapping emerged when the dust came into contact with oxygen inside the cabin, revealing chemical interactions not observable in vacuum. The abrasive nature of the dust caused wear on mechanical components and posed potential risks for long-term exploration. These findings became critical considerations for future missions. Beyond the physical environment lies a deeper psychological reality. Standing on the moon places a human being in a state of profound isolation. There is no atmosphere, no life, and no immediate possibility of rescue. Communication with Earth is delayed by approximately 1.3 seconds each way, reinforcing the distance between worlds. Astronauts were acutely aware that their survival depended entirely on engineered systems, their suits, their spacecraft, and the precision of mission planning. Gene Kranz emphasized this mindset with a statement that would become emblematic of the mission's philosophy: failure is not an option. Despite the inherent risks, astronauts maintained focus, conducting scientific experiments, collecting lunar samples, and deploying instruments designed to study the moon's composition and structure. These efforts yielded significant discoveries. Analysis of lunar rocks confirmed that the moon formed approximately 4.5 billion years ago, likely as a result of a massive collision between the early Earth and a Mars-sized body, a theory now known as the giant impact hypothesis. The moon's surface, largely unchanged by geological activity, preserves a record of ancient impacts, offering insight into the early history of the solar system. Instruments left behind, such as retroreflectors, continue to enable precise measurements of the distance between Earth and the moon, contributing to ongoing scientific research. To stand on the moon is to exist, however briefly, outside the natural conditions that shaped human life. It is to move in reduced gravity, to see without atmospheric distortion, and to experience a silence unlike any found on Earth. Yet beyond these physical differences lies something more profound. The experience is not defined solely by what is encountered, but by what is understood. From the surface of the moon, Earth appears small, fragile, and singular, a reminder of both the limits and the potential of human existence. The testimonies of astronauts, supported by scientific evidence, suggest that standing on the moon is not merely a technical achievement. It is a transformation of perspective, a moment in which humanity, for the first time, looked back upon itself from another world and recognized its place within the vast expanse of the universe.